Beneath the calm surface of our planet lies a world of unimaginable heat, pressure, and power. A hidden realm where rock melts, continents drift, and the forces that shaped Earth are still alive today. Volcanoes are not merely mountains that erupt with fire. They are windows into the very heart of our planet. They are creators and destroyers, symbols of both life and death, chaos and renewal. From ancient myths to modern science, volcanoes have fascinated humanity for thousands of years. Early civilizations believed they were the homes of gods, demons, or supernatural forces. Today, we know that volcanoes are the result of complex geological processes deep within the Earth, processes that continue to reshape our world. What is a volcano? A volcano is an opening in the Earth's crust through which molten rock, gases, and ash escape from below the surface. This molten rock is called magma while it is underground. Once it reaches the surface, it is known as lava. Along with lava, volcanoes release volcanic gases such as water vapor, carbon dioxide, sulfur dioxide, and other toxic substances. Volcanoes form where the Earth's tectonic plates meet, separate, or slide past one another. They can also form in the middle of plates, above hot spots where plumes of hot magma rise from deep within the mantle. There are more than 1,500 potentially active volcanoes on Earth today, and millions more lie dormant or extinct. Some erupt gently, allowing lava to flow slowly across the land. Others explode with devastating force, sending ash clouds tens of kilometers into the sky. The birth of volcanoes. To understand volcanoes, we must journey deep below the Earth's crust. Beneath the surface lies the mantle, a vast layer of semi-molten rock. Extreme heat and pressure cause portions of this rock to melt, forming magma. Because magma is lighter than the surrounding solid rock, it slowly rises toward the surface. As magma moves upward, it collects in magma chambers beneath the Earth's crust. Pressure builds over time, and when it becomes too great, the magma forces its way through cracks and weak points in the crust. This is the moment a volcano is born. Volcanoes often grow layer by layer. Each eruption deposits lava, ash, and rock around the opening, slowly building the volcanic structure over thousands or even millions of years. Types of volcanoes. Not all volcanoes are the same. Scientists classify them based on their shape, size, and eruption style. Shield volcanoes are broad and gently sloping. They form from fluid lava that can travel long distances. Mauna Loa in Hawaii is the largest shield volcano on Earth and one of the most active. Stratovolcanoes, also known as composite volcanoes, are tall, steep, and often symmetrical. They are built from layers of lava, ash, and volcanic debris. These volcanoes are known for their powerful and explosive eruptions. Mount Fuji in Japan and Mount Vesuvius in Italy are famous examples. Cinder cone volcanoes are smaller and simpler in structure. They form from volcanic fragments ejected into the air that fall back around the vent. Though usually short-lived, they can still be dangerous. Calderas are massive depressions formed when a volcano erupts so violently that its magma chamber collapses. Some of the most powerful eruptions in Earth's history created calderas, such as Yellowstone in the United States. Volcanic eruptions. Power-unleashed volcanic eruptions can be among the most violent natural events on Earth. When pressure inside a magma chamber is suddenly released, the result can be catastrophic. Explosive eruptions can hurl ash, rocks, and gas high into the atmosphere. Pyroclastic flows, fast-moving clouds of superheated gas, ash, and debris, can race down volcanic slopes at speeds exceeding 700 kilometers per hour, destroying everything in their path. Lava flows, while slower, are equally destructive. They can bury towns, forests, and farmland under rivers of molten rock. Volcanic ash can collapse roofs, contaminate water supplies, and disrupt air travel thousands of kilometers away. Some eruptions are so powerful that they affect the entire planet. The eruption of Mount Tambora in 1815 caused the year without a summer, leading to global temperature drops, crop failures, and widespread famine. Volcanoes and life. Despite their destructive power, volcanoes are also essential to life on Earth. Volcanic eruptions release minerals and nutrients that enrich the soil, making volcanic regions some of the most fertile agricultural lands in the world. Volcanoes also played a critical role in shaping Earth's atmosphere. Early volcanic activity released gases that formed the atmosphere and oceans, creating conditions suitable for life. Even today, life thrives in extreme volcanic environments. Microorganisms live near volcanic vents on the ocean floor, surviving in boiling water and toxic chemicals. These organisms provide clues about how life may exist on other planets. Underwater volcanoes. Most of Earth's volcanic activity happens beneath the oceans. Underwater volcanoes, known as submarine volcanoes, form along mid-ocean ridges where tectonic plates pull apart. These eruptions rarely make headlines, but they are responsible for creating new oceanic crust and shaping the seafloor. Some underwater volcanoes grow tall enough to emerge above the surface, forming volcanic islands. Hydrothermal vents near underwater volcanoes support unique ecosystems that exist without sunlight, relying instead on chemical energy from the Earth's interior. Famous volcanic disasters throughout history. Volcanic eruptions have changed the course of civilizations. In 79 AD, Mount Vesuvius erupted, burying the Roman cities of Pompeii and Herculaneum under ash and pumice. The disaster preserved the cities in time, offering a haunting snapshot of ancient life. In 1883, Krakatoa erupted with such force that it was heard thousands of kilometers away. The explosion destroyed the island, triggered massive tsunamis, and caused global climate effects. In 1980, Mount St. Helens in the United States erupted violently, flattening forests and killing dozens. The eruption reshaped the landscape and provided scientists with invaluable data about volcanic behavior. Monitoring and predicting volcanoes. Modern science has made great strides in understanding volcanoes, but predicting eruptions remains a challenge. Scientists monitor volcanoes using seismographs, satellite imagery, gas sensors, and ground deformation measurements. Small earthquakes often signal that magma is moving beneath the surface. Changes in gas emissions and ground swelling can also indicate an impending eruption. Early warning systems have saved countless lives, allowing communities to evacuate before disaster strikes. However, volcanoes remain unpredictable, reminding us of nature's ultimate power. As long as the Earth remains geologically active, volcanoes will continue to erupt. Climate change does not cause volcanoes, but volcanic eruptions can influence climate by releasing ash and gases that reflect sunlight. Some scientists study ancient super-eruptions to understand the risks they pose in the future. While rare, a super-eruption could have devastating global consequences. Yet volcanoes are not just threats, they are reminders that Earth is alive, constantly changing, and far more powerful than humanity. Volcanoes are among the most awe-inspiring forces of nature. They remind us that beneath our feet lies a restless planet, shaped by fire and time. They destroy, but they also create. They terrify, yet they give life. From the depths of the mantle to the peaks of towering mountains, volcanoes connect us to the origins of our world. They are the heartbeat of the Earth, pulsing with energy, shaping landscapes, and reminding us that nature always has the final word.